Welcome in, everyone. And also, because I know some people don't like chatting, you know, through audio all the time, you can also say hello in the chat in case you don't want to turn on your mic or camera. And as people are joining in, I think, we're waiting a few minutes before we get to the presentation part. And I know that David usually cover quickly some news or project updates from the ecosystem.
Yeah, yeah, I can cover that section.
And cool, more people are rolling in. How's everyone doing? Also, if you're new here, definitely make sure to say hello. Whether if you want to turn on your mic and camera, that's always awesome. But also, if you want to say hello in the chat, say hello in there again, and maybe put in where you're watching from or tuning in from. That's always kind of fun. You can also share more about like projects you're working on. If you're using Flyte currently, that's always interesting to hear about as well. And then I think we can probably get into some of the new stuff pretty shortly here. But
Yeah,
yeah,
absolutely. All right, so yeah, let's get started. Let me see. All right, I'll share my screen real quick. Um, there you go. So a couple of things I found interesting, and again, this is an open section. The news from the ecosystem, uh it's probably very it's pretending to be something useful, but it's open for you to add stuff that you consider relevant. Some stuff that we found during the last month we thought was interesting. Hugging Face co-founder released a series. I think it's 2 lectures on building LLMs almost from scratch. Very interesting. It's almost 3 hours of content right there on YouTube. So again, if you're um longing to learn more about LLM stuff and how it's built, definitely a good resource. Next up, this repo. I mean, this library, a tool. I don't know it deeply. Probably some other folks can comment better, but it promises to make PyTorch models up to 40% faster. Not sure how, but definitely interesting. Right. Also, I always enjoy these awesome whatever repos, the comprehensive list of resources. This one is on AI agents. And it's interesting because it clearly separates open source from closed source agents. So a good starting point to get up to speed on different agents available today. All right, and probably if you saw watch the viral video from Devin and Old Promises. I know there are also some other alternatives to building open AI coding assistants. This is Open Devin, nothing less, and with clear mission of building an open source um, AI companion agent for writing code. All right, any comment around this?
I haven't messed around with Devin at all yet, but I'm curious because I keep hearing so much about it, and I don't know if anyone else has messed with it, but I'm curious like if it is better at all than any of the other like co-pilots or anything like that around coding. I don't know if anyone's actually messed with it either.
I'm not.
We're all busy programming, I guess, without it.
Yeah, maybe. Cool. So yeah, let's move to the next section. Community and project updates. So yeah, contributors of the month. Again, a huge shout out to Lisbon and Blake Jackson. I think Blake is here. And yeah, and Cornelis too. So welcome, guys. Thank you for your support. This is something is interesting in my opinion because yeah, Cornelis contributed a values file, a missing values file for GCP for the Flyte binary chart, Helm chart, which is really interesting. But he's been also willing to help other community folks, and at the same time, Cornelis is learning Flyte. And Blake is, I mean, he's been awesome helping also other community members. So this is a good example that contributions is not only code, but helping the community grow and support other peers is also equally valuable here. So huge shout out to both of you. I don't know if Cornelis or Blake would like to say something. Thank you, Cornelis. That's awesome. Cool. Next up, there is an idea coming from a community member. In summary, a way to kind of provide a badge for projects or organizations using Flyte to kind of showcase, hey, this project or this system uses Flyte, and the badge will have a link back to the Flyte documentation. So the original idea was the Flyte carrier, but probably something more concrete will be Flyte workflows. Source is here. It's pretty simple. But yeah, the discussion is open. It's a nice idea to kind of start standardizing the way adopters will refer to or will sign out, hey, this is using Flyte on the inside. So feel free to chime in or learn more. I had to ask a couple of questions because at the beginning I didn't understand. So feel free to go to the discussion, give your opinions. Integration survey, yeah. Who loves surveys? Not many people, but we have this survey open. In parallel, I've been reaching out directly to folks who we probably know have some reference. They're using specific integrations. The idea of this survey is basically answer a simple question: is this particular integration working or not? And if not, what's the problem? And if it's working but could be better, what are those missing elements that you consider are necessary in terms of documentation or features or etc. It's kind of yeah, building an inventory of the state of the art of integrations, both plugins and agents. Uh, so yeah, your help is really appreciated on giving feedback. The survey is kind of short, it's pretty short. And the results will be posted on the community repo. This is the sole scope of the integrations inventory working group. As a reminder, and if you're new to Flyte and the Flyte project, we have working groups, and the idea of working groups is to have a specific goal, a specific deliverable in mind, and they are meant to be short-lived. So this is why we started this working group to perform this assessment, and that's it. So your help will be really appreciated there.
And I just shared the link to most of the things we talked about, but specifically like the survey in the chat as well, if you want to click it and fill it out there.
Thank you. Thank you so much, Sage. Next up, there's a new blog. Keaton wrote a blog providing a nice introduction to the Flyte Agents framework. Again, if you're new to the project, in summary, the Agents framework is a new mechanism with a much lower barrier to build or consume integrations with Flyte. So definitely check it out. It also has links to the code itself and the documentation. So a good starting point if you're curious on the agents framework. And finally, if for some reason you happen to be attending Open Source Summit North America, that will take place in Seattle in a couple of weeks, there's a talk from Eduardo, who's part of one of the maintainers of Flyte, on showing how to fine-tune LLMs using open source tooling, including Flyte. So definitely very interesting. This is a co-located event. It's the Open Space AI, not related to OpenAI, Open AI and Data Forum. part of the Open Source Summit. So if you happen to be attending, it will be great to see you there. And that's it in terms of community updates. Any comment, question?
We'll probably also have time for other questions at the end after the presentations as well.
Right. Back to you, my friend.
Awesome. Well, then I think we're ready for Mike and Bram. If you're ready to start presentation.
Yeah.
Just going to be orchestrating efficiency in our ML workflows. I'm sure you'll do an introduction about that here as well.
Yeah, cool. So yeah, hi everyone. My name's Michael from Adaga. Going to go through sort of our journey with Flyte at Adaga, sort of how we chose to use Flyte and how we're now extending our use of Flyte throughout the business. Yeah, so brief introduction. My name is Michael Tinsley. I'm a machine learning engineer in the MLOps team at Adaga. I've been at Adaga for around 18 months or so now. My background is in data science, ML engineering, and operations roles. We also have Bram in the audience who I work with. And our MLOps team is basically responsible for data science tooling, best practices, as well as managing data science infrastructure. So a bit of background on Adaga. We're a London-based company that specializes in natural language processing and information graphs. So our product is called Vantage, and it's a information intelligence tool. So the idea is it enables the distillation of high volume and high velocity data to support decision making in defense, national security, government, and industry. With Vantage, we fuse open source and internal information together into a single unified analysis tool. Everything's ingested automatically and is instantly translated, transcribed, and prepared to be analyzed together. And then our ML sits on top of that, enriches the data to add insight, and aims to automate a lot of the time-intensive aspects of analysis. So yeah, ML at Adaga. So natural language processing is our bread and butter, really. So typically our like model training pipelines are NLP focused. When we're training models, typically grabbing data from DVC, S3, Postgres, and graph databases. And then in terms of the frameworks that we're using, we're pretty agnostic, generally using the right tool for the job. But typically it's PyTorch, Hugging Face, and Spacey are our most commonly used libraries. In terms of MLOps, we've been doing MLOps at Adaga for a long time now, since way before I joined. But when I joined, we're starting to face challenges with our existing tooling as requirements have gradually changed, and generally saw sort of it play out like this. So obviously models just generally have gotten larger and larger in NLP. And along with that, sort of training requirements have grown in complexity quite a lot. So we started bumping into limitations of our existing tooling. And then to work around that, we'd have to implement bespoke solutions and workarounds for the different challenges we were facing. And then this all culminates in just the writing of pipelines for our data scientists just would become a blocker, as they'd need specific workarounds being implemented, and there essentially wasn't a happy path for a lot of use cases. So in light of this, we started looking at replacing our existing tooling in early 2023. And we had been using Pachyderm extensively internally for ML training jobs and data processing pipelines. We were having a few Pachyderm specific issues as well. So one of the major ones was the cost of running pipelines. So for those that haven't come across Pachyderm before, it's a data pipeline tool, but it really focuses on data streaming, and it really excels at that. But the problem was we weren't necessarily making the most of those features. A lot of our pipelines didn't need data streaming in. How Pachyderm works is you obviously define your workflow, and those pods will run 24/7, essentially waiting for new data to come in. And as soon as new data comes in, the pipeline's like automatically triggered and processes that data. But because those pods are constantly running, for the ML use case where these pods typically have like high resource requests and limits, they would sit there sort of sitting on a bunch of compute, not using it for the majority of the time. And you can work around this. You can set these to scale down to 0, but it's not the default sort of configuration. So it just added a burden of ensuring that everything had been configured correctly for pipelines. We were also having challenges with the developer experience in general. So actually writing pipelines was quite difficult. As yeah, you basically have to mimic the sort of remote environment locally. So Pachyderm functions off sort of input directories and output directories, which are mounted to the pod. And you basically have to mimic those mounted directories locally. And then we'd also have to replicate either the full data set or a subset of the data locally. All this was just added a bit of friction to the process. And then, yeah, this all just made updating pipelines and deploying new pipelines quite a clunky process, which we never really found an optimal way to manage. So we had a set of requirements for a new tool where our main objectives were to sort of reduce the cost of running pipelines, make it easier and quicker to develop pipelines, and to reduce the friction to get them deployed. And then from an admin side of things, we obviously want it to be robust, so we don't have to keep picking it up. Easy to deploy and manage, and from like a personal point of view, preferably open source with a good active community that we can sort of lean on for help with things. And if we can do all of these things with the same tool, then everyone is happy. We reduce costs and make things easier for our users. So when we were looking for a new tool, we had a set of requirements, including those things I just mentioned, but then some more specific ones. So we ideally wanted a Python SDK. So all our data scientists are writing their code in Python. Pachyderm didn't have this. So you'd basically write scripts, I guess, more similar to Argo workflows, which made testing workflows more difficult. We also wanted a good UI and visibility of workflows so we can look and see what's going on. Ideally, Kubernetes native, again, just so we can just be confident that it's easy to manage. And similar to Pachyderm, we just needed the data lineage so we can see what models are using what data and models being trained on which data, etc. So we gathered a big list of potential solutions from more general workflow orchestration tools like Airflow and Argo workflows, to more ML specific tools like Kubeflow, Metaflow, like Flyte, obviously, and there's a range of other tools we looked at. And we checked all these tools off against our requirements, tried to understand how they would fit in with our existing processes and tools. and Flyte consistently met all these requirements and was the only tool that met all these requirements. So we proceeded with an internal user testing group where we had a subset of our data scientists got together, and we basically gave them the task of either implementing some of the existing pipelines or new pipelines using Flyte, and trying to get them to grips with both Flyte and Flytekit and how it all works. And the feedback from that was really positive, especially things like being able to write in pure type-hinted Python. Everyone really liked, which was quite a big difference coming from Pachyderm. Again, being able to test tasks really easily with PyTest in a sort of a way that they're used to writing tests, and being easily able to parameterize workflows, which again wasn't something that we had with Pachyderm. One of the use cases that came out of that testing group on the parameterization was one of our data scientists put together a workflow which aggregated a bunch of data, loaded in a model from Hugging Face, pushed all that data through Hugging Face, and sort of wrote the outputs, basically to test multiple different models. And through the parameterization of the workflow, we could basically easily just log on to the Flyte console, find the workflow, test multiple different models, and see how the outputs compared really easily. Not having to worry about provisioning all the GPUs, etc. So it made it a lot quicker than developing or running these same tests locally. So with that feedback in mind, we sort of proceeded we decided to proceed with Flyte. So we were sort of planning the migration. Obviously, we had a lot of workflows that needed migrating over, so it's quite daunting. So working out the best way of how can we do this smoothly. And one of the things that I found was we'd actually lift and shift a lot of our existing Pachyderm pipelines over to Flyte using container tasks. So the way that Pachyderm works is very similar to a container task. With our existing model or existing Pachyderm tasks and containers, we had them already created, working. And those containers basically have all the Python dependencies needed. They have a Python script in it, and they would just point to the relevant directory. So we could use that same logic with container tasks. Instead of actually having to rewrite the task or rebuild any containers, we could reuse the same ones, and we just have to rewrite the actual workflow itself, which in Pachyderm is a YAML file. We convert that over to the Flytekit Python workflow and just point it at these tasks. So that sort of removed a lot of the the stress with migrating, as it gave us a really nice path to migrate stuff over. So with that in mind, we went about deploying Flyte. So for our internal use case, we're using this the Flyte binary deployment, which was largely straightforward. Straightforward thanks to Flyte community, a lot of help there. And also, David's Flyte the Hard Way guide was a massive help, especially around getting authentication all configured. Once we actually migrated, we didn't even need to use the container tasks, as we found rewriting the workflows using Flyte was really straightforward. So the benefits that we found of Flyte, so I said before, one of the things we were really aiming for was to reduce costs. And this has been sort of facilitated by Flyte in a few different ways. So one of them is just the difference in how Flyte operates compared to Pachyderm, where we don't have all these pods constantly spun up waiting for new data. But also the integration with Spot instances has been huge. So this is something that we wanted and was a bit of a wider push to move as many workloads on Spot instances as possible. Spot instances themselves, like obviously most alternatives to Flyte can do this as well. But one thing we're always mindful of is if we have a GPU training job that's being running for a day, we also don't want AWS to reclaim that and lose all that checkpoint, lose all the checkpoints and the logs that we've all the progress we made on that training job. This is where intra-task checkpointing comes into play. So this, it seems to be a feature that didn't find on any other options really, and is a huge help, especially combined with spot instances. So being able to put expensive jobs onto GPU spot nodes, and we can just have the confidence that if AWS reclaim that instance, we can pick up from where we left off and not lose any information. Along with, I think Hugging Face introduced a callback maybe last year. So it's a really easy integration now. It's like a one-line change. So that's really cool. In terms of like how much this has saved us, it's obviously we made a bunch of changes at the same time, but we think we've decreased infrastructure costs by around 50% by making this change, which is huge. But yeah, as I said, that's a bunch of different changes all at the same time to give those numbers. The other really cool feature that has basically removed a lot of that friction and challenges that we were bumping into previously was all the features of Flyte that basically enable the power of Kubernetes, as I've put it. So yeah, we have this sort of happy path using Flyte where we use straightforward Flyte tasks for the majority of use cases. And when we need to scale, we have the options built right within Flyte, and we don't have to go searching for other tools to sort of bodge together a fix for them. So for those things, like for parallelizable jobs, we have map tasks, which we're using quite a bit at the moment. We'll talk about in a moment. And then when we need to grow past a single node, we have Ray. And then having the Ray cluster lifecycle managed with Flyte is awesome. And again, that just removes some of that friction. And then when we need extra resources for tasks, we have pod templates. I find this has the benefit of tying infrastructure to a task, which is cool. And then that's all in code. All of these features together sort of enabled us to work with LLMs that I don't think we would have been able to with our previous setup. So yeah, it's been a really good solution. So moving forward, so at this point, all our data scientists are using Flyte internally for all their sort of training jobs and data pipelines. But our product advantage is using Kafka-based pipelines, which works really well, but it's a bit of a blocker when data science want to add maybe a new model or a new feature, and they just want to quickly add it and test it and see how stuff works on real data. So we were looking at this problem, and then for a few reasons. So Flyte's caching system was seen as really beneficial for this. Obviously, our data scientists had an internal knowledge of Flyte, and we also had the Flyte UI, so it gives a really good overview of what's going on. It was decided that we'd use Flyte to augment our current Kafka-based pipeline with this sort of extra pipeline that data scientists would be able to easily add new features to. So yeah, our engineers sort of set about building a system around Flyte to sort of integrate it. And it kind of looks like this. So we have a pipeline service, which is basically the interconnect between the existing Kafka pipeline and the new Flyte pipeline. The pipeline service receives documents and batches them up for the workflow. And then it will trigger the workflow with those documents, monitor the status of Flyte, and then report that status back to downstream tasks. And this is has been a big bit of work, but it essentially means that data science can easily come in there, update this workflow, and add new elements onto it quickly without requiring back-end engineers to do Kafka wizardry. So one of the challenges that we knew we'd bump into with using Flyte is sort of how we register workflows. So for our internal data science use case, registering workflows from a local machine or from CI works well. But for our production use case, we sort of enforce strict GitOps, and we use Argo CD to deploy all our resources. So we're trying to figure out how we can do this. So our engineers have made this custom Flyte registration operator. So essentially, we have this workflow now where we develop the workflow, or the Flyte workflow, test, and in the CI, we test it, package it, and push it to an artifact store. Then when we want to register a workflow, we deploy this registration resource. The operator picks this up, fetches the archive from the artifact store, and registers it with the given parameters, which has been quite a simple implementation, but really effective for allowing us to adhere to our GitOps processes while still using Flyte. So next steps and challenges. So we have this setup working currently, but it's early days, so there's definitely improvements to be made. I think some of those things are investigating agents. I think now, especially, they're in general availability. We have a lot of calls to internal and external services where with agents, we should be able to offload those long running tasks to an agent and better use resource there. I also think investigating dynamic workflows could be really interesting. So we're currently using map tasks quite a bit, but there's places where perhaps dynamic workflows could be more beneficial for us. And then some of those challenges that we're faced with this setup. So it's from our engineers with Flyte Sandbox. So we're using Flyte Sandbox for like local development. I've had some reports of tasks getting stuck in initializing, which I'm not sure if it's due to running out of memory or what, but the task gets stuck and then it requires a teardown of the Flyte Sandbox. Yeah, as I said, we're using Sandbox for local development, but also for integration testing of the pipeline service. So trying to work out if there's a better way to manage that and way we can improve that integration testing. In terms of managing concurrency, so we have concurrency at multiple levels in these workflow, both because we're using map tasks quite a bit, but we'll also have concurrency at the workflow level. So we'll have multiple executions of a workflow, and those workflows will be fanning out with multiple map tasks. So it's taken some tinkering to figure out sensible limits at both levels. We obviously don't want it to fan out infinitely, but we also don't want excess latency on the system. So we're trying to figure out if there's a way to sort of dynamically configure this during the execution of workflows, so we can sort of tinker with those numbers and work out for a given set of documents what those limits should be. And then finally, this is one from our engineers who are all Golang engineers, but yeah, they love a Golang Flytekit SDK. Currently using the API to directly hit Flyte, so it works. But yeah, they aren't going to be converted on Python, I don't think. So yeah, so that's a brief run through of our usage of Flyte at Adaga. So again, thank you for having us. Yeah, I can try and answer any questions if anyone has any.
That was awesome. Thank you.
That's pretty nice. Hey, my name is Ketan. I've seen you around, Mike. I also want to add a few other things that Mike has been helping the community a lot as well. So thank you, Mike, for all your contributions. Appreciate it highly. I did see a couple things for the Golang SDK. Would you be open to actually designing one? That's the problem with SDKs is designing the SDK. The code is that hard. People can write it, but
I think you'd want me to stay away from that. I'm not a Go engineer.
yeah, Go is a weird language to design an SDK that is beautiful, and it's not beautiful. Go is meant to be simple. Nothing to do with beauty. But yeah, cool. Thank you.
Any other questions from anyone? Also, feel free to put questions in the chat if you don't want to turn on your microphone as well.
Yeah, I had one. I don't know if the question is for Michael and Bram or more for the audience, but when you describe the pipeline service, could that be an agent? I mean, it sounds to me like the very description of what will an agent will do. But I don't know if you could please go back to that slide for everyone to kind of remember that. Yeah, having this service that is kind of watching for documents in this case, and also watching for the status of Flyte and doing this interaction. Yeah, it looks to me like a potential agent, but I don't know. What do you all think?
Yeah, it's an interesting idea. So I think a lot of this work started before agents were sort of in general availability. But yeah, I think like a lot of the use case probably could be an agent, but there is a lot of other sort of business logic in that service as well. So yeah, it's something to think about for sure.
Yeah, I actually don't know if it'll be an agent. The agent needs to be scheduled. And so when does the agent get scheduled? This is more like a reactive, constantly running system that reacts to external document availability. You could use a sensor. I don't think people know about my thoughts on sensors, but yeah, of course, that's added to Flyte now, and people should be able to use sensors. The thing about sensors is like, when do you schedule a sensor? If you knew that the data was going to be available, just trigger an API, because Flyte has an API to trigger. And that's what the pipeline service is doing. But yeah, I think a sensor-like agent could be done.
Could you elaborate a little bit what a sensor is in Flyte?
I think it's an idea derived from Airflow. So credit where it's due. Sensors essentially a way to sense for things happening outside of the Flyte world as a task. And so once the sensing is done, that means the thing is complete, or you have a timeout. Timeout causes an abort. If the sensor is complete, it should move the workflow forward. So that's a sensor. So it's essentially sensing for anything. And a common use case is sensing for files or availability of data in S3 or messages on queues, etc.
Awesome. Any other questions or comments from anyone watching? Again, you can also throw them in the chat if you want as well.
Yeah, sorry, I had one more. So when you mentioned the idea of or the need to set concurrency limits kind of dynamically, I'm thinking here, it made me remind that famous Rob Pike talk on how, yeah, parallelism is not equal to concurrency. So I'm aware of, for example, how to set limits on parallelism for large fan out workflows. But well, here when you mention concurrency, yeah, probably I'd like to understand better the need here. And see if we can discuss further this.
Yeah, so essentially, yeah, we have this pipeline service which gets batched with documents, but those documents can change in size quite a bit. And then once we start adding enrichments, sort of that data size sort of balloons a lot. So yeah, we essentially we limit how many executions we launch in parallel, but also the parallelism of the map task. But I guess it's been a challenge to sort of work out how to tweak those two numbers. So we manage the workflow concurrency or parallelism, how many workflows we execute from the pipeline service. The pipeline service manages that at the moment. But then to actually sort of work out those two numbers together of what they both should be has been quite hard, because yeah, you basically go in and update the actual workflow, register that workflow, and then get that published, and then tweaking this other value as well. I think we can configure that per project or per domain in the actual Flyte deployment. But yeah, it's essentially just a lot of moving parts, which it's been quite difficult to sort of tailor for our use case. So yeah.
There is an issue, an RFC that's open, I think, and I think there is active work happening for limiting the total number of specific launch plan executions that can happen concurrently. So, for example, you may want to limit it to only one, like it's in the case of a schedule, or you may want to limit it to like N. It's an opt-in feature, and I think that's how the work is. Please contribute to it. I think there are a lot of folks already.
Yeah, that sounds yeah, exactly what we're looking for, to be honest. Yeah, I'll have a look for that RFC.
Yeah, I don't know if it's an RFC an issue. I just commented on it a couple of days ago, but I saw a few people were talking about it.
Yeah, so I'll add a link to the notes.
Awesome. Anything else from anyone?
I think Blake has a question. Sorry, I answered it in the comments, but
Oh yeah. I don't know if you want to elaborate further on it. Blake said, would it be good to get thoughts from the Flyte team around how much business logic should live in an agent versus writing custom application using the Flyte API? And I think you commented back on that, Kathan, a little bit on as long as you can schedule, you think the Flyte agents are good, but there's different patterns you can choose.
yeah, there's no right or wrong. I think I have resisted adding sensors for a long time, and I came into the communities honestly. So, but I think there's no right or wrong. It's just different ways. We have to understand a specific application and its need at that point to actually design the right thing. One thing though, I do want to ask the entire communities to see, like, how do we speed up data flow through the system? And there is this literal streams interface that we have talked about. See, like, I think there are people who are interested in contributing to it, and that would be really, really amazing, and make certain other kind of use cases possible, which are different than, I'm saying agent, sorry for the divergence, but I have the slide open in front of me and I remembered what Michael Tinsley was saying about some of their work using Pachyderm.
Awesome. Yeah, any other questions or comments for Mike and Bram, but also for the larger Flyte community? If not, also As most of you probably have experience, you can go into the Flyte Slack group. I'll share a link to that again as well. But that's super active. And if you have questions, you can always join that group if you haven't already and ask them there. People are saying thank you for the presentation, Mike and Bram, in the chat. So thank you so much for coming on and presenting. That was really cool.
No problem.
And with that, I guess if there's no other probably questions and comments, we can probably wrap up the Zoom call here. David, I'm not sure if you have anything else you want to add in before we wrap up.
No, thanks again. And for the next meeting that will happen May, I can remember the day, the first Tuesday in May. We'll have a team from Sender, again covering their journey, their interesting journey to with Flyte.
Awesome. Looking forward to it. Thank you again, everyone, for coming in and asking questions. Special thank you to Mike and Bram for presenting, and David for also hosting. And your Flyte the Hard Way guide got a great shout out too in the talk. So people should check that out too if they're looking for a Flyte guide.
Yeah, I'm happy for it to be useful, and hopefully we'll make it even better in the near future.
Awesome. Well, thank you, everyone. We'll go ahead and end the Zoom call.
Thank you.
Cheers.
Bye.
Bye.